Alright, the first quadrilateral we're going to learn about is the trapezoid. So, the picture of a trapezoid, a basic trapezoid, looks like this. And the technical definition for a trapezoid is one pair of parallel sides. So in order for it to be a trapezoid, it just has to have one set of parallel sides. So if you notice here, our set of parallel sides are right here. And what they'll do on the pictures is they will draw arrows like this, and that will indicate that those two lines are parallel. And the parallel sides are called the bases. So you have a top base and you have a bottom base. So every trapezoid has two bases. And the ones that are non-parallel, so these sides over here, the non-parallel sides are called the legs. So two bases and two legs. So this is a basic trapezoid. What we're going to work with, though, because these basic trapezoids aren't like any fun, they don't have any cool like properties, so we are going to work with these kinds of trapezoids. So this trapezoid, as I'm going to draw it first, that we're going to work with looks like this. And this is probably a typical trapezoid that you're used to. So we still have a pair of parallel bases right here. So I'm going to label those as my bases. And then put my arrows here so I know that those are in fact parallel. And we still have our legs. So our leg is going to be over here. But here's the difference. I don't know if you can tell, and I tried to draw this, but the legs are special. The legs are congruent to each other. So do you remember, think about in a triangle, when you had a triangle that had two legs or two sides that were congruent, what was that called? Hopefully you're saying to yourself, that was an isosceles triangle. So this is an isosceles trapezoid. So this is the trapezoid that we are going to be working with more in this class because they have more special properties. So we're going to get right to what those properties are. So a trapezoid has 5 properties that we're going to talk about. So the first one we already named, and we said that the legs are equal or congruent. So I'm going to go ahead and mark those in my picture. So if you ever see something that says, hey, this leg is equal to 10, the other leg has got to be equal to 10. Alright, the second property is, remember in an isosceles triangle, not only were the legs congruent, but the angles were congruent too. So it's the same thing in a trapezoid, that the base angles are congruent. So remember our base is down here at the bottom, so that means these two bottom angles are going to be the same measurement, and the two base angles at the top are going to be the same measurement. Okay, but not all 4 of them are the same. You can definitely tell that the one on the bottom are 2 acute angles, the one at the top are 2 obtuse angles. So let's just, throw a number in there. So let's go ahead and say that this one is 50. And then we're going to say, obviously, the other one has to be 50. So we learned in the last class that in every quadrilateral, how many degrees is inside every quadrilateral? If you remember, since there's 2 triangles in here, if I draw that line in there, I'm going to have 360 degrees. So every quadrilateral has 360 degrees. So right now, I have already 50 plus 50, so I already have 100 degrees. So if I subtract that, I'm left with 260 degrees that has to be split up evenly between the 2 angles up at the top here. So if I divide this by 2, I'm going to get 130. So each of these top angles here are going to be 130 degrees. So we all add up to 360, we got the 2 base angles equal, so what do you notice exciting about, let's say, opposite angles? Maybe these angles right here, ones that are opposite of each other or diagonal from each other. Hopefully you're seeing they're not equal, but they are equal to 180. So opposite angles, if you look right here, are equal to 180, or we can use a fancy dancy word that says they are equal to 180 or supplementary. So that's going to be a fun rule that we're going to use a lot of math with later. Alright, so those are the first three rules. Let's move on to the fourth and fifth. So I'm going to draw some pictures. I'm going to give you a little time to draw. Alright, the last two rules are more like segments that are inside of a trapezoid, and things that are going to be helpful again when we start doing the second part of trapezoids, which is going to be adding equations in these bad boys. So in number 4, these deal with the diagonals. So if you look real close at the diagonals, there is something special about their measurements. The diagonals of a trapezoid are congruent. So, aka the same measurement. It's also special because when they intersect right here, they make this part and this part the same measurement, and they make the other two, this part and this part, also the same measurement. So not only do they, we can't say they bisect because it's not perfect, but they do make two equal parts to each other when the diagonals are cut in half. So keep that in mind. So for example, let's say that this whole line, let's name it something. Let's name it DS. So if DS is going to be 10, and let's say that we gave this small segment here a measurement of 2, then that means this one would be 8. And then the other diagonal would be exactly the same because they're congruent. Alright, the fifth rule is we have this new line in here, which is the middle. So do you remember what something is called, a segment that is drawn in the middle? It's called a median. Okay, in the median, if you remember in statistics, median means like the middle or like an average of the middle. So what you're going to do to find the measurement of this is you're going to take the two bases. So you're going to take base and base, and you'll add them together, so b plus b, and then you'll cut it in half. And if you cut it in half, you'll end up with how long this middle segment is. So for example, let's say that my top base is going to be 4 and my bottom base is 10. So if I know that, all I do is add them together. I get 14, cut it in half, and I get 7. So that means my median, or the middle segment, is 7. So keep this in mind. Again, this formula is going to be helpful when we're solving equations in the next section. So stay tuned for Trap Part 2.